Welcome to the CDD Vault Visualization Module Feature Tour. The CDD Vault informatics platform includes a powerful data visualization tool, which allows you to more easily draw conclusions on your complex research data. As indicated here in my activity and registration table, once I have a search, I can click the blue Launch Visualization button, and that will pull all of my data into a session of CDD Vault visualization, where by default I will get a scatter plot at the top, a copy of my data table down here at the bottom, and a series of histogram filters over on the right. To begin filtering through your data, you can either add in custom filters, being the columns of data you have brought in. In order to start filtering, you can slide the dragger bars on your filters, or you could type in a particular molecular weight range in this case. In addition, if you go down to your data table, you'll notice a filter icon on your structures. This is called SuperSAR, and if you click this, we have broken your small molecule structures into 1 and 2 connection point substructures to help with filtering. So for instance, you could choose this primary amine to filter based off of, and you'll notice that it is present in 107 out of 167 molecules. If instead you prefer to draw your own structure, you could simply launch the structure editor and then draw in your own substructure of interest to filter through your data. For now, let's go back to the scatter plot. You can affect the X and Y axis of the scatter plot, choosing a specific axis range or toggling between log and linear scale. And in addition, you can set the axes to any data type that you have brought in. So mutant 1 inhibition in this case, and I will leave it by log P. In addition, you can set up to 3 more parameters for the scatter plot. So you can set the color to log P, for instance, either using the color wheel to set color, or we have a binning option. So you can set the specific colors of these bins to something that works for your research, and you can even affect the size of these bins by dragging or typing in a specific value. In addition, you could add new bins with specific colors. Next, you can affect the shape of the data points, set to molecular weight in this case, and the size of the data points, set to mutant 2 inhibition. Finally, if you have a very dense data plot, you can split the plot up by a certain parameter and even change the opacity of the data in order to start seeing a density cloud. If interested, you can also add statistics to your plot, whether it be a linear regression or standard error, standard deviation bars if it was appropriate. Closing this out, once you have added additional parameters to your graph, some trends might start sticking out and you can zoom in on a particular area of interest. In addition, hovering over any of the data points, you will see a pop-up of your molecule, and if you left-click, you get a scorecard with all of your data. You can then toggle through all of your selected molecules and even have a link back to the place in the registration system where that molecule is registered. In addition, you can pin any of the molecules directly to the graph area to start making a publication quality image, and you can change the size of the thumbnail and also the settings on the thumbnail, turning off the structure or even turning on additional parameters and updating the text for those parameters. If you like this graph and you wanted to export it, you can save it as a PNG or publication quality PDF. But if you had more analysis to do, you can add up to 3 more graphs to this area, whether it be another scatter plot, a bar chart, a histogram, or a 3D scatter plot. In this case, I will add a histogram, and you can change the axes and the parameters as well as colors, just as we have been discussing. And the cool thing is that all of these graphs are interconnected, so as I make a selection in one, you will notice the data points populating in the other graphs. I might be done with my analysis now, having selected 146 out of 167 molecules, but if I had additional analysis to do, I could add in R group decomposition. Clicking the R button in the toolbar, we display all of the pre-designated cores, but you could also launch the structure editor in order to draw your own cores. Upon selecting or drawing a core, we will plot all of your cores, so in this case, 26 molecules. And if I zoomed in on a particular area of interest, you will see the R1 and R2 start to populate, but you can also hover over particular points in order to see your highlighted core and the R1 and R2 groups. In addition, you can color, shape, and size affect these data points just as we did with the scatter plot. Once you are done with your analysis, you have a few options. You can open up the data table down at the bottom, in which we will highlight the molecule as well as the core R1 and R2 group. And you can even change the settings here in order to add particular color, so matching the log P coloration that we had, and you can rearrange your columns if necessary. You can even sort based on particular numeric columns. And I can export that data table to Excel. I can also copy a share link and send this exact session of visualization to one of my colleagues with the same permissions as me. Or I could add all of this data to a collection back in my registration system. So these 26 molecules would be added to a collection that is available to other users. And the last option I have is to launch a session of CDD visualization outside of your own private and secure vault. And here you can import files with screening assay data or pre-QC your data before importing it to CDD Vault.